Hello and welcome to Chosen Few, the one and only place for you. I'm Ian Santin from Chosen Few Software, and today I'm talking about SAVE, Software Analog Video Emulation. It's a project that I've been excited about for years now. Actually, it's just a little over a month after the 2-year anniversary of the project. So, happy birthday to the SAVE project, and I'm hoping to excite all of you with some brand new news for the SAVE project. Now, you might be wondering what exactly that is. Well, in the last video, I talked to you guys, or I briefly mentioned about the fact that SAVE has a hardware component to it that I was kind of keeping under wraps back then. But that's what I'm hoping to talk about today and kind of disambiguate. I think the best place to start with that is with the idea. I'm going to give you guys the narrative as I kind of developed this idea in my head and started making it happen. So it all starts really with this, a Raspberry Pi 3B Plus. The idea was to leverage the power of this tiny computer and specifically this little output port here. And effectively, what I want to do is transmit a digitally generated signal with this Raspberry Pi. You must be wondering what's been stopping me from using this to accomplish that, to basically drive an analog video signal and plug it directly into something like a CRT, one of those humpback TVs if you don't know what a CRT is by name. What was stopping me from doing that is the fact that the current method that I had for generating those signals with software using SAVE, it was way too slow to even drive that signal anywhere near real time, which is basically what it needs to be. So my original idea to fix this was to use a multi-threaded approach to split up the work of modulating the image line by line and have all of the CPU threads available on a given computer to work on those simultaneously. I thought it was going to be really easy and simple, but the implementation fails. Why? Because of the color carrier phase, which is really all that I'll say on the matter. It took me quite a bit of research to get to the point of realizing that. Or not realizing it, but finding a workaround for it. And that's kind of, I'd say, part of the secret sauce of SAVE that I wouldn't really want to give away. So I was stuck on that. The multi-threading wasn't working, and I figured, well, damn, it's not going to work. But some more research actually revealed the workaround that I mentioned just now, and it basically went to the next level and allowed for the usage of the holy grail of computer parallelization, which is, of course, the GPU. I basically worked on that for several days. I worked on the implementation for several days. I remember I coded up like probably half of it in about a day. I was working on it all day. And then I kind of took a break from it because it was some pretty heavy duty coding. But then I finally came back to it. Took another day or two to do the rest of the implementation. Then I needed a couple more days to work out bugs. And then I finally had something that actually worked. I was successful. And this is the crazy part. It's freaking fast. Not just like fast, like really fast. Like faster than I need it to be to make this little doodad do its thing. So the idea, I'll switch to future Ian here to kind of explain the whole setup that I came up with to... Alright, past Ian, I'll take it from here. He didn't actually know what he was gonna say. So yeah, essentially the idea here is to have our main computer with a GPU. We connect that via the network to our Raspberry Pi, which has two outputs, one for ground, one for signal, that goes to the TV. And then we have network cables going back to the main computer for some feedback. All right, thanks, future Ian. So with all of that set up in mind, let's talk about the results, some facts and figures, numbers. Like I said, the GPU modulation is fast, really fast. Roughly 1 second of processing time is needed for a full 15 seconds of video. And keep in mind, this is the worst case. Lots of time is wasted on waiting for stuff to copy to and from the GPU, copying around buffers and stuff. This is something that multi-threading can easily fix. So with that worst case processing speed in mind, what's the latency like? Well, there's a minimum latency of the system of around 2 frames at 29.97 frames per second. And that is due to the nature of how the GPU modulation works. I won't go into too much detail. Interlaced digital video is supported and implemented correctly as well. So you can take in interlaced video from a .mpeg file, MPEG-2 file, and you can convert the interlaced digital frames into interlaced analog fields correctly. Keep in mind, right now, only NTSC video is implemented, but PAL support is planned, as well as possibly CCAM. But yeah, that's basically the GPU modulation side of things. You may be wondering next, well, future Ian talked about networking. And what I'll say about that is the minimum required link speed for this whole system to work is around 200 megabits per second. And as far as the minimum requirements for the Raspberry Pi computationally, as well as output-wise, the Raspberry Pi application clock speed is going to have to be exactly 12 megahertz the way that things are implemented right now, making the output signal bandwidth around 6 megahertz at baseband, which means that this little guy is going to have to do quite a bit of the grunt work as well, basically spitting out data from these pins as fast as possible. But yeah, I'm really excited about this, guys. I am so excited to know what you guys even think of this, the idea of it, because it's just something that I've wanted to do for so long now. The fact that it's actually starting to become a reality, the fact that it's actually now feasible. All the parts are within my grasp. All the pieces of the puzzle are within my grasp. I just have to put them together now. So yeah, I'm really excited to share what comes next with you guys. And before I end this video for you guys today, I want to share a little clip that I generated using the new modulator and demodulator to kind of satisfy your hunger for at least a little bit longer before I hopefully upload next an actual working hardware demo. So yeah, thanks for watching, guys, and I'll see you guys next time. Bye-bye!